Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Let's talk about how to simplify rational expressions. So what is a rational expression to begin with? Well, it's just a fraction whose numerator and denominator are non-zero polynomials. And so we're essentially going to be trying to factor these polynomials. So now, what is the domain? Well, it excludes values that make the denominator zero. So that's something that we do have to keep in mind when we write our final answer, because when we factor out, we might have some factors that cancel out. What I mean by that is there's a factor in the numerator and the denominator. But even though it cancels out, we have to keep in mind what value of x would have made that equal to zero. We have to exclude that from our domain. So you'll see me doing that when we do our examples in this video. Now, what is simplified form? It's just when our numerator and denominator have no common factors other than positive or negative 1. So what are our steps to simplifying? We want to factor our numerator and denominator, divide out any factors that are common to both the numerator and the denominator. So let's jump right in and let's do 3 examples in this video. So number 1, we have x squared minus x minus 12 divided by x squared minus 9. So we have a trinomial on the top and we have a binomial on the bottom. So hopefully you notice about the bottom that is what we call the difference of 2 squares. So we'll get to that in just a second. Let's factor the top. So the top, we have a b value of negative 1 and a c value of negative 12. So we need to be thinking, okay, what adds to negative 1 but multiplies to negative 12? And hopefully we're thinking negative 4 and 3. So we could factor the top as x minus 4 times x plus 3. Now, the difference of 2 squares, we know that's going to factor as x plus the square root of 9 times x minus the square root of 9. So x plus 3 times x minus 3. All right, so now looking at what we have right now, what values for x do we need to exclude from the domain? Well, our denominator can't be 0, right? So x cannot be negative 3 because negative 3 plus 3 is 0, and x can't be positive 3. Okay, so let's just keep those 2 numbers in mind. Now look what happens. We have an x plus 3 in the top and an x plus 3 in the bottom. So essentially those will cancel out because whenever you divide something by itself, it's 1. So now we're left with x minus 4 over x minus 3. Okay, now that's our final answer, but what 2 values do we need to exclude from our domain? We said negative 3 and 3. Well, 3 is obvious because we still have x minus 3 in the denominator, but we got rid of the factor x plus 3, so we need to say, hey, x cannot be negative 3, right? Because negative 3 was our number or our value for x that would have given us a value of 0 in x plus 3. All right, number 2, 2x plus 2 divided by x squared plus 4x plus 3. So let's just factor out a 2 from the numerator. So we have 2, and that would be x plus 1. Now our denominator, a trinomial, so what adds to 4 and multiplies to 3? 1 and 3. So we have x plus 1 times x plus 3. So now we see, once again, what 2 values do we need to exclude from our domain? Well, that would be negative 1 and negative 3, right? Because if I add negative 1 to 1, 0, negative 3 to 3, 0. So we just need to keep that in mind, okay? So maybe we'll make a note of it right here. So x cannot be negative 1, x cannot be negative 3. Now our x plus 1s are going to cancel out. So we're just left with 2 over x plus 3, comma, well, x can't be negative 3, that's obvious because we still have x plus 3 in the denominator, but we do need to write over here, hey, remember, x can't be negative 1, right? Because that would have made our original polynomial expression undefined, okay? All right, number 3, we have x squared plus 14x plus 49 divided by x squared minus 49. So we saw the difference of 2 squares in number 1. We do have a difference of 2 squares again here in number 3 as x squared minus 49. And also, hopefully you're noticing that we have a perfect square trinomial in the numerator, right? So that's x squared plus 14x plus 49. So remember, a perfect square trinomial, that's going to factor as the square of a binomial. So we could write this as x plus 7 quantity squared over x plus 7 times x minus 7. Okay, now what is x plus 7? Let's expand that. X plus 7 quantity squared, excuse me. So that's x plus 7 times x plus 7 divided by x plus 7 times x minus 7. All right, so a lot of 7s. So once again, what can x not be? It cannot be negative 7, and it cannot be positive 7. So we see one of our plus 7s and will cancel out from the top and the bottom, but we're left with x plus 7 in the top and x minus 7 in the bottom. But we do need to remember that x cannot be negative 7 or positive 7? Well, it's pretty obvious that x can't be 7 because we still have x minus 7 in the denominator. So we just need to say, hey, remember that x cannot be negative 7, okay? And that is how we can simplify some rational expressions.